Okay, so I think this is fourth lecture. Okay, so if you remember in our last lecture, we had some discussion about the cavity, right? Cavity in solid, right? That's what we had seen. And we remember, if you visit a dentist, it will categorize three types of the cavity in your teeth. The first one is removable, second one is pole, and third one is essential. So type of the cavity. So see, so the type of cavity are two types. The one is
isolated, non-isolated,
and another one is non-isolated. What is the meaning of non-isolated means? You cannot separate it, right? Because we are in complex analysis, so instead of having an interval a comma b around the point x, I x comma delta, here we are in a disk, in a ball, meaning non-isolated cavity means if two cavities are so close, you cannot separate it, right? So like if you see the chalk or if you see this plane, right? If you are taking any ball, whatever radius is, definitely this ball will contain infinitely many points of this world. You cannot have a ball having only one point of this board, right? Or if you take a ball around your finger, definitely this any ball will contain huge amount of tissue from your hand. You do not have such a ball that contains only one ball. Okay, so meaning isolated cavity means we can isolate it with respect to a disk. What is the meaning? Suppose that is there exists a disk. Disk means for me it is always open, right? Such that a disk containing Z0 comma delta contains only one cavity G0. What is this meaning? The meaning is if you draw the diagram, suppose this is the G0, this is the radial delta. So it's look a solid everywhere except the point G0. Alright? Cavity means it is a puncture in solid. So the puncture at one point only. Alright? So this is the puncture at G0 only. So this is a disk. Disk means representation of an analytic function everywhere except G0. Okay? If you remember the bicycle, if you go somewhere, the puncture, if you in a tube, one puncture is known as isolated singularity. So isolated means this is a puncture in a solid. But if you remember, if at same point so many punctures are there, then the tube will be broken, right? You cannot maintain it. So what I mean that if your tube, your bicycle tube is punctured only one point, that is called the isolated. If it is punctured, suppose this is your bicycle tube, and if in this region so many punctures are there, so definitely if so many punctures will go right, there will be some gap, right? So this is not a puncture. Puncture means isolated, which is separate. Okay. Okay, so if you remember, yesterday we had seen 1 over sine 1 over d was analytic everywhere except zeros of this, right? So because the point at which this denominator 0, the function will go to the infinity. So the puncture or cavity, how to calculate? Just calculate a 0 of this, right? Sine 1 by d equal to 0. Because once it is 0, the function will be infinity. That's what it is the problem. So this was you got is sine n pi. If you remember, 1 over d is equal to n pi. So d is equal to n belong to integer. It means that if you draw the geometry of this function, then it will be solid everywhere except d points. This is a solid everywhere except d points, right? So what are these points? If you remember, if you draw n is equal to 1, then this will be, if you remember, this is the 0, n is equal to 1, 1 upon pi, correct? N is equal to 2, 1 upon 2 pi, alright? 1 upon 5 pi. So at this point, this is the puncture, means make it puncture. Okay? But if you remember, 1 upon pi, 1 upon 2 pi, right? N is equal to 2 pi. So as n increase, if you increase the n is equal to 1 pi, 1 upon 2 pi, this distance is bigger than this. That's why, because n tending to infinity, if you remember, n tending to infinity, your g tending to 0. Right? This meaning that this is the definition of sequence. Meaning, as your sequence growing, your this is collecting at a particular point, and it is happening if the distance is decreasing, right? If distance is not decreasing, it will not tend to the 0. So this distance is bigger than this bigger than this. Even if you calculate 1 upon pi minus 1 upon 2 pi will be always greater than 1 upon 2 pi minus 1 upon 3 pi. Right? So if you can notice this here, 1 upon pi minus 1 upon 2 pi, this will be greater than 1 upon 2 pi. Right? And so on. That's why the distance is always decreasing. So if you remember, the puncture of this solid at this following point. But the mind is, once we are here, I can make a disk and I can give you the guarantee that this disk contains only one puncture. See, this disk contains only one puncture. We can reduce the radius. This is also contain only one puncture. But if you remember, as you will keep on moving towards the 0, the moment you are making any disk around 0, this will contain not only 0, many more puncture. That's it, that the distance is decreasing, it will happen near 0, this point will be so close, you cannot separate it out. Alright? So what is this happening? At 0, so many punctures are together, sufficient punctures are together. So at 0, punctures are piled up. They are so close, right? In calculus, in first year or second year, you had said the limit point. Limit point means the points are collected to each other. So this 0, if you remember, this is called isolated puncture, isolated cavity. isolated cavity, but 0 is not isolated cavity because so many cavities, so many punctures are there. So this implies that this have isolated puncture or isolated cavity are 0, everything 1 upon n pi and such that n belongs to integers minus 0 and non-isolated puncture is only 0. Okay. Why I am telling you whatever books you are going to study, you can go and find out. You cannot get such a clear-cut definition, and your book need more than 100 years then come on this concept. Okay. So I think you are now aware because to understand anything with the help of example. Once your theory grow up properly, then you can write a definition in each and everything. But if you are writing definition in first chapter, it is not good to for the better understanding. Okay? Any doubt? Write fast. Then? Yes. Any doubt here? You guys should go to Amit because he has been taking some classes. Okay? But बारहवीं के लिए नहीं, बारहवीं के बाद में तुम्हें छोड़ दो।
तो सर वो इसके पहले आता है एक मिनट के बाद। एक्चुअली वो तक टाइम नहीं होता ना, टेबल जब वो कल खड़ी हुई थी ना। हाँ हमें तो लेट हो जाता है, तो ऐसे पहले लेंगे।
ठीक है?
लेट हो जाता है, इसलिए पहले लेंगे।
Okay. Anyway, so what will you start? What will you start? Today you have a class 120 or 12? 12. Okay. But in the next time, I can already my class will be 12:40. Okay. So do not schedule any other class, right? Yes. So the lecture number 4. Yeah. So we had seen right. Now come to the point. The type of isolated. Okay, there are 3 types. So today is LPP class or real class? Real or LPP?
Real one.
Okay. Okay, there are 3 types: removable, whole, and essential. Okay, so what is the removable means? So let okay, I said let Z naught is a isolated function of solid f defined from D to C. Fine. Let Z naught is a isolated function of this function defined from D be a subset of C to C. It is fine to everyone? Okay. So f is a function from D be a subset of C to C. Its meaning that this implies that a disk containing G naught radial delta. This is a disk. This looks solid, but puncture at G naught only, right? That's why it is isolated. This is a puncture at Z naught only. Then how will you check it is not a solid at G naught? Okay, then third definition is what is the removable? So what we will do there, limit G tending to G naught f of G exists and finite. If limit exists and finite and also puncture at that point, the function is puncture at Z naught and limit also exists and finite. Then you will say it is a, then your G naught will be removable. Singularity or puncture, both are the same thing. Up here. Okay. Or F is puncture and Z naught. The second, if you have any doubt, you can simply magnitude also. So, if I am calculating the limit, again you remember you had done the limiting things in BSc first year and enter everywhere, right? So, these are the concepts that you have to learn from there, not from this one. So, Z tending to Z naught, if your function are going to the infinity, right? Then this G naught is known as the pole at G naught, right? Suppose you are going home, then definitely you should have some speed, right? You are going with 10 speed of 10 km per hour, 20 km per hour. Then I can also calculate here. This is limit is tending to the infinity. Then I can find out the speed of the function. Means what is the speed of going to the infinity? For example, if you see 1 over G, if I say limit G tending to 0 and limit G tending to 0, 1 over G square, similarly 1 upon Z power 100, and this speed will be 1, this speed will be 2, this speed will be 100. So, this is the pole at Z naught. Also we can calculate and the speed of f tending to the infinity at G naught is called order of pole. All right. It is fine.
Yes, you guys can class chal.
This is not first year, but this is final year, no, first year नहीं, final year. हाँ,
फर्स्ट ईयर
मुझे नहीं पता था. Okay. Okay, so this is the procedure that we will tell you, we will find out somehow to do that. Okay, the third one I had said how many types? There are 3 types. So one is removable, another one is pole. So what is left is essential. If it is not removable and pole, then definitely it is essential. This is the one definition, right? Otherwise, what? One more definition I can write: limit g tending to g naught f of g. If you remember, here this is exist and finite. This meaning that limit exists in C. Limit going to the infinity, it means that limit exists in C union infinity, and this is known as the Riemann sphere. Riemann sphere, okay. Somewhere they denote it as C hat. One limit is finite in C, another one Riemann sphere. If you take the whole ball, what is the Riemann sphere? Suppose you have seen your arm now, the same thing. Essentially, here limit does not exist in C hat, meaning C union infinity. Limit not exist anywhere, meaning sometime it will go to the infinity, sometime will get 1 or something. Means it will be depend on the path. Here it will always go to the infinity. Whatever path you are choosing, you are coming from this way, this way, this way, it will always take you to the infinity. But this is not the case. Okay. So here limit does not exist in C hat. All right. For example, limit g tending to 0 sin 1 over g. Right. So I can move along the 2 directions, one along the real axis, right? What will be this? It will oscillate plus minus 1 between, right? Here, sometime plus, right? So this is answer done. It means that limit does not exist. Even one more step, limit y tending to 0, this will be sine hyperbolic y, right? Something hyperbolic y, right? This way it will go to the infinity. So one along you are going to the infinity, another along you are not going to the infinity. Limit does not exist. Okay? Is it fine to everyone?
Yes.
Any doubt there? So one question. Find the type of function Complete. Zero value to 1. Apply the hospital rule. Cos D. Put z equal to 0 to 1, right? You know removable discontinuity definition, right? So limit if this value of function is different. This is finite. Therefore, g is equal to 0 is removable. Whole limit g tending to 2 1 over g minus 2 whole square. Calculate. Another. So let me calculate this. Limit g tending to 0. It will be 0 by 0 form. We will apply the L'Hospital rule. Infinity. This implies that it will go to infinity at 2. This implies that okay. Any doubt here? ये clear everyone? Or if any doubt is there? If no doubt, then now we go again and change this part. You know the government of India will be there that you are late. Go to the other below.
ये भी लिखा है तो सब लोग पहले ही आए थे ना क्लास में
Yes, so we are seeing three types. Let us rewrite some more definition based on it. So the first one, zeros of solid or analytic function. Okay. So let f define now a subset of complex number to a complex number, and then zeros of this is denoted as g of f is collection of all those complex numbers such that f of g is 0. Alright? Where function is 0. So after here, this is a set, right? This is also set. So if it is set, we can find the limit point. So once we have, then we will calculate the limit point. But I like the word pilot point. Okay? Means how many points are so close you cannot separate it. Okay? So we will find out the limit point or the pilot point of this set. So there will be two cases. Maybe it is 5 or it is not 5. Right? Two cases are possible. For example, f z equal to 1 upon g minus 2 whole square into 1 upon g minus 3 whole power 4. Right? Or we can remove this z minus 2 power 4, z minus 3 power 4. Then if I calculate the g of here, this will be simply 2 and 3. Right? This is a finite set. The zeros are some distance. So the limit point g of f of p by the point pp will be the 5. Another example we can see f of g is equal to sine 1 over g. If you want to calculate the zeros of the function, this you got n pi n belongs to the integer. Right? We had seen this just before. And we also calculated the pilot point, that is the limit point. It was nothing but it is a 0. Okay. It is fine to everyone? So this pilot point of the set is 0. So there is a one note, you can write it and we will prove it later. Okay. Pilot point of ZF is known as isolated essential single bracket or function. Okay. So you have to calculate for zeros and then find the limit point. If limit point is there, that is called an essential singularity. Right? It is fine to everyone?
Yes.
So now, right two way. Either you can apply direct definition, that will be also give you answer. Another way you can just find the zeros, right? That also you can calculate. So anyway, we are finding the zeros of this ZF, and one more of you should write order of. Now we are going to calculate what is the order. Like I said, some function is tending to the zero. What is the speed? Right? If you remember here, f of g is equal to 1. F of g is equal to d. F of g is equal to g square. What is the order? At here order 0, it is not tending to 0. This order will be 1. This order will be 2. Right? What point? Point 2. If I have fg equal to g minus 2 to the power 4, then what will be the order? Order will be 4. This function tending to the 0 at j is equal to 2 of the speed 4. Right? What is this meaning? Let us write it mathematically. So the mathematically means it is telling you. So then, let f of g naught be equal to 0, f dash g naught 0, and so on. F dash k minus 1 at g naught 0, but f dash k g naught non-zero. This implies that f has a 0 at g naught of order k. It is clear to everyone?
Yes, sir.
So if you remember, this is the thing that whatever I have written here, it is mathematically written there. So if you remember, you are telling the order tending to the 0 is 1, right here.
Yes.
So if you take 0 equal to 0, but phi derivative will be 1. So you have to keep on finding the derivative. The minimum order at which the function is non-zero, that will be the order of zeros. See here, fg is equal to, let us check this by mathematics. So tell me, f of 2 will be 0 here? Yes?
Yes, sir.
F dash 2 again 0.
Yes, sir.
It will be 4z minus 2 ka cube.
Yes.
Right? Similarly, third derivative, fourth derivative, at the last part you will get 24. F fourth derivative, this will give you 24, which is non-zero. All other derivative will be 0, right? So this is the procedure of calculating the order. Alright? So can you calculate it for how to find out the order of tending to infinity? That is the order of 1. Any idea? So, if you know very well, this function have 0 of order k at point g naught. What is this meaning? It's meaning that your function tending to the 0 with the speed of k, right? So if I write, if we write it in the denominator, see what, can you tell me something about this? G of g is equal to 1 over f of g. If this function, by this definition, tending to the 0 with speed k at g naught, that we have seen, this is a function tending to the 0 with speed k at g naught, then I think this whole function 1 over fg or our gz will tend to the infinity with speed k at g naught, and this k is known as the order of pole of gz or 1 over f. Alright? So let us calculate. Find the fg is equal to g square sin z. Find the zeros. Find zeros and their order also. Do fast. The last day your physics class happened? Physics lecture? No. But I can know. Oh my God, it's only 40-minute class. So you always keep this slot, that's why I fix it, right? Keep this slot till 12:43, always 10 to 12:40, okay? You can schedule whatever after 12:40 continues the whole day and night, no problem. So I'm just coming within a minute, and by the time I think she will erase it also.
इसका चार्ज लिमिट डिफरेंशिएट करूंगा 0 0 तो इसमें निकालना तो मैं करते वो उससे ज़्यादा टर्म्स आते जा रहे हैं। हाँ जितना करोगे चाहे कि अनंत फंक्शन और ये दोनों मतलब दो है ना। हाँ इसका ऑर्डर कितना होगा ये ऑर्डर क्या होगा 2 होगा 3 2 अगर हम लोग x प्लस हाँ x प्लस आई वाई हाँ x प्लस आई वाई तो वो स्क्वायर कर सकते हैं ये होगा काफी मैटर 0 पे नहीं आएगा कितनी बार हाँ 0 रखोगे तो इनटू सर 0 नहीं आएगा डिफरेंशिएट तो 0 हो जाएगा।
So anyway, so we have a function this, if you remember, f dash, sorry, f0 will be 0, f dash 0 will be 0,
Yes, of course.
f double dash 0 and f triple dash 0 will not be the 0. Okay, this implies that this function has 0 at g equal to 0 of order 3. This implies that 1 upon fg has a pole of order 3 at g equal to 0. Fine. So, did you calculate this? This is same answer or you have different answer? Okay. Also, this function f of n pi is 0 and f dash n pi will not be 0. What is n? N is non-zero. If n is non-zero, then this will be 0. This will not be the 0. F of n pi is 0, right? So f dash n pi non-zero. First derivative non-zero. This implies that f g is equal to g square sin v as 0 of order 1 at z equal to n pi n belong to integers minus 0. Will it fine? Derivative you know how to calculate, right? क्या उसका लेंगे? Are you fine?
Yes, sir.
Do not ask the derivative, right? I can calculate in 10, right? So, also, this implies that 1 over fg has pole or simple pole. Simple pole means order 1. Okay, simple pole at g equal to at n pi n belong to integer minus 0. infinitely many simple code. Yes. And then last option is 1 over here has infinitely many simple code. 1 over here has infinitely many simple code. Okay? So tell me the correct answer. Think 1 minute and tell. Yes. Think. Nadi, what is the answer? Answer. थोड़ा सा या वीडियो
तो थोड़ा सा सहयोग चाहिए हमको ताकि पता चले कि बस अपनी क्या बात है
अभी आफ्टर क्लास आएंगे What is the expansion of sin b? Sin x expansion? No. Is it g minus g cube or g minus g square? I think this is right.
Yes, sir.
That is your.
Yes, sir. Same.
Yes, answer that. I think last class. Last. So yeah, 1 over g square, 1 over 3 factorial, these are the. Anyway, you give me the answer that one.
I can say
Okay. Yes. So what is your answer here? Yes. So this is a function fg equal to sin square z and over z power 5. Then has pole at 0, removable at 0, essential at 0, none of that. Yes. So you tell me one thing, if I have a function h over k, this is also tending to 0, this is also tending to 0. What can you say the whole function tending to 0 or infinity? So the answer will be if this is also tending to 0, this is also tending to 0, then it will be depend on the speed. So case number 1, if speed of h is bigger than speed of k, this speed is faster, this speed is less at some particular point g naught, then h by k definitely will tend to the 0. But another case, if this speed is more than this, then h by k will tend to the infinity. Alright? So similarly, if you remember this one, this is the question. Anyway, so f has 0 of order 2, that is also fine, right? No. F has 0 of order 1, that is also correct. Because at n pi, the function has 0 of order 1 only, right? At n pi. F has infinitely many zeros, that is also correct.
yes.
The point at which it vanishes n pi, f has a pole of order 3 at 0, that is also correct, right? And f has infinitely many simple poles, that is also correct. No, 1 over f has. 1 over f tending to 0, infinity, right? Not f tending to. Okay, so yes.
सर
Hmm.
सर कल अमित सर बोले थे क्लास करने के लिए 12 बजे हम लोग जाएं
When?
12 बजे से
Today or before?
टुडे
But you are aware that I have a class, right?
सर इसी टाइम मैं पहले ही अवेयर हूं ना हां सर तो जब हम आए थे तभी मैसेज
No, I am not telling it. What I am telling it, but you are already aware that till 12:30 there will be class, right?
लेकिन सर बोले थे कि वो हम लोग को
No, आप लोगों ने you guys had said something that you have a class or not. I am not telling him. What I am telling if your schedule is there, 1:20 already will be scheduled, na?
सर जो 120 से था तो हम लोग उस दिन गए इसलिए लेट हो गया था सर बोले काफी लेट हो गया
हाँ।
और फिर वो बोले कि 12 बजे से 124 हां
Yeah. Anyway, so wait some more time. Right now not possible. Wait some more time.
सर
And
आप मुझे
So-
प्लीज सर आज छोड़ दीजिए फिर हम लोग आगे से मैनेज करेंगे
no. I mean wait little bit until unless it is very less lecture. So that is not possible right now. Wait. So yeah, let me solve this problem and then go.
यस सर
So we have a function f is equal to sin square z over z power 5. If you see this, f is equal to sin square z over z power 5. This is the numerator, this is the denominator. So what I will do, suppose this is the numerator, this is the denominator, right? Remember, n of 0 is 0, n dash 0 is 0, but n dash double dash 0 is non-zero. Right? Similarly, the denominator 0 at 0, derivative non-zero, double derivative also 0, sorry, and so on. The denominator, fourth derivative at 0 will be 0, but denominator, fifth derivative will not be the 0. Okay? In this ways, the both function is tending to 0, but this speed is faster than this.
यस सर
So this speed is bigger than this implies total function will go to the infinity. This is, and then what will be the speed? Definitely this speed will reduce some speed, na? This is also tending to 0, this is also tending to 0. So definitely some speed will be reduced. So what it will be? Then f has pole at g is equal to 0 of order 5 minus 2, that is the 3. So what you have to do? You have to subtract the order. Okay. These are the questions also I had written down because I cannot rewrite this again. Here you have to just notice some point. Sin g over g. If you remember, this whole function not tending to the infinity, or is it? This function not going to the infinity. This function is going to the infinity. This function going to the infinity. Another one, this function is also going to the infinity. All right? I think it was something cube. Yes. This is also going to the infinity. So if some function going to the infinity, what are the conclusion if you notice? This is, we did some expansion and we got so many terms. This is from your 9th class also binomial expansion you had done. When you open the expansion, the term that taking this solid to the infinity is only one term. Here, how many terms? This term is taking to the infinity, right? So in the next class, what we will do that we will do the expansion and we will find out how many terms of the function taking to the infinity. Alright? These things will not take to the infinity. So the case will be three cases. Case number 1, there will be no term. Case number 2, finite term, right? Maybe one term or two term. And case number 3 will be infinite term. Right? But infinite term also can take it to infinity. Like if you write the c z minus 2 and so on, g minus 2 whole square and so on, keep on writing. This all the term taking to the infinity. So the answer will be case number 1 when no term taking to the infinity, this is a removable. If only finite term are taking to the infinity, this will be the whole puncture. If infinite term are there taking to the infinity, then this is known as the essential. Okay, so in the next lecture, you be prepared for expansion thing. So there are so many methods to find the type of the puncture in the solid. If infinite term are taken to the infinity, then this is essential. If only finite, then whole. Otherwise, this is the removable. Okay. So the next term, we will learn how to look at these kind of a term. Okay. Thank you. And be on time tomorrow class.